In part 4 of our lesson on graphs of secant and cosecant, we will graph a cosecant function. In this example, we're being asked to sketch one period of the graph of y equals 2 times the cosecant of the quantity 1/2 x minus pi over 6 plus 3. Let's go ahead and check your understanding on this one. So pause the video, work the example on your own, then restart the video to check your answer. So first, we'll find a formula for all the vertical asymptotes, and then we'll use that formula to find the 3 vertical asymptotes of our shifted cycle. We know to find the formula for all the vertical asymptotes, we need to set the argument of the function equal to where the normal vertical asymptotes for cosecant happen. Our argument is 1/2 x minus pi over 6, and the normal vertical asymptotes for cosecant occur at n pi. So the first thing we'll do is add pi over 6 to both sides. So now we'll have 1/2 x is equal to pi over 6 plus n pi. We'll get a common denominator on that right-hand side. So now we have 1/2 x is pi plus. Now to get the common denominator, we're going to need to multiply n pi times 6 over 6. So we'll get pi plus 6n pi over 6. To get the x by itself, we need to multiply both sides times 2. So we'll take the left-hand side times 2, which means we'll need to take the right-hand side times 2. And we'll have x is equal to, well, this 2 and this 6 will cancel. We know that 2 goes into 6 3 times. So we're going to get that x is equal to pi plus 6n pi over 3. And that's our formula for all the vertical asymptotes. Now we can use that formula to find the 3 vertical asymptotes of our cycle here. We know we'll be plugging in for n. And for cosecant, we need to plug in n is 0, 1, and 2. If we put a 0 in for n, it will wipe out this term, and we're left with pi over 3. If we put a 1 in for n, this becomes 6 pi. So we get pi plus 6 pi will be 7 pi over 3. And if we put a 2 in for the n, this will become 12 pi. So we'll have pi plus 12 pi is 13 pi over 3. The next step is to solve the inequality for the shifted cycle. We know we have to put the argument of the function in between the starting and ending values. And for cosecant, that's 0 and 2 pi. So our argument is 1/2 x minus pi over 6. That's got to go in between 0 and 2 pi. We will add pi over 6 to each piece of the inequality. and it becomes pi over 6 is less than 1/2 x is less than, well, the 2 pi, we need to write the 2 pi as 12 pi over 6 so that we get a common denominator. And 12 pi over 6 plus pi over 6 will be 13 pi over 6. And now we're ready to multiply each piece of the inequality by 2 to get the x by itself. And we get pi over 3 is less than x is less than 13 pi over 3. Our cycle will start at pi over 3, and we expect that that should be an asymptote, and there it is. And the cycle will end at 13 pi over 3, and we expect that to be the third asymptote, which it is. We can now find all these attributes of the graph, but first we need to take the equation and put it into the standard form. So this will become 2 times the cosecant. We have to factor out that 1/2, which means multiply everything on the inside times 2. So if we take 1/2 x times 2, we get x, and then minus, and we take pi over 6 times 2, and we get pi over 3, and we have a plus 3. So now we know A, B, C, and D. We know the period is equal to 2 pi over B. We know that B is 1/2. So 2 pi divided by 1/2 is 4 pi. So this is going to be a horizontal stretch, meaning the period got longer. Instead of 2 pi, this period is going to be 4 pi. The vertical stretch or compression comes from the absolute value of A, and A is equal to 2. So we're taking the absolute value of 2, which is 2. So this will be a vertical stretch. Every y value will be multiplied times 2. The phase shift comes from C. C is what comes after the minus sign, so that is pi over 3, which means it's positive, so it's shifting to the right. The vertical shift comes from letter D, which is positive 3, so that means it is shifting up. The domain we get for free from the vertical asymptotes, because everywhere there is a vertical asymptote, the function cannot live there. So we know that x cannot be pi plus 6n pi over 3. The range for cosecant we know starts out -infinity to -1, union 1 to positive infinity. We know that it will be affected by the vertical stretch, so we have absolute value of A is equal to 2, so that will take our range and turn it into -infinity to -2, union 2 to plus infinity. The range is also affected by the vertical shift, and we know that d is equal to positive 3. Every y value has to shift up by 3, so that means the range is going to become negative infinity to positive 1, because if I take negative 2 and add 3, I get positive 1. Union, instead of 2, we have to add 3, so we'll get 5 to plus infinity. So there's our new range that we're going to expect to see on the graph. We're ready to take the shifted cycle now and break it into 4 equal pieces. We know the starting x value is pi over 3. The ending x value is 13 pi over 3. Now, since these have the same denominator, it's 3, we can go ahead and write it there. Pi plus 13 pi is 14 pi. Half of 14 pi is 7 pi. For the quarter point, we're going to add pi, and 7 pi is 8 pi. Half of that is 4 pi over 3. To find the 3/4 point, we'll add 7 and 13 is 20, so half of that will be 10 pi over 3. Or you can always show the work. If you can't do those in your head, that's okay. Just show the work, write it out, add them up, divide by 2, which really multiply by a half. Now we're ready to move on and find our expected y values. We know that we have 3 vertical asymptotes already. The first is at pi over 3. The second is at 7 pi over 3. And the third is at 13 pi over 3. We know that the quarter point for cosecant, the expected value is 1, and the 3/4 point is -1. And these will be affected by a and d. We know that a is equal to 2, and we know that d is equal to plus 3. So we have to take each y value, multiply it times 2, and add 3. So 1 times 2 plus 3 becomes 5. -1 times 2 is -2, plus 3 is 1. We need to check at least one of these values. Let's go ahead and check them both, so whichever one you decided to do, you can check your answers. If we put 4 pi over 3 in for x, I'm going to choose this version because this has a pi over 3 and we'll have a common denominator already. So we would have 2 times the cosecant of 1/2 times 4 pi over 3 is going to go in for the x. So 4 pi over 3 minus 1 pi over 3 is 3 pi over 3, which is pi. And then we have to add 3. Now, of course, this is pi over 2, the cosecant of pi over 2. You might want to think of it as 1 over the sine of pi over 2. We know the sine of pi over 2 is 1, so the cosecant of pi over 2 is the reciprocal of 1, which is just 1. So this works out to be 5, just what we expected it to be. Let's go ahead and check x equals 10 pi over 3. We'll plug it into that same equation. 2 times the cosecant of 1/2 times, we're putting in 10 pi over 3 minus 1 pi over 3 is 9 pi over 3. 9 pi over 3 reduces to 3 pi. And then we have plus 3. So this argument is just 3 pi over 2. The cosecant of 3 pi over 2, just think, 1 over the sine of 3 pi over 2. The sine of 3 pi over 2 is -1. So that means the reciprocal of -1 is -1. So we have 2 times -1 plus 3. And this equals +1, which checks out. Now we're ready to make our graph. Looking at our x values, they all have a denominator of 3, so we'll want to go by pi over 3's. So we've got pi over 3, then 2, 3, 4 pi over 3, then 5, 6, 7 pi over 3, 8, 9, 10 pi over 3, 11, 12, 13 pi over 3, our y values, we have to plot a 1 and a 5, so it looks like we'll want to go by 1's. We'll put a 1 and then 2, 3, 4, 5 here. Now when we're plotting our 5 key values, we know that pi over 3 is going to be an asymptote. 7 pi over 3 is going to be an asymptote. And 13 pi over 3 is going to be an asymptote. We have to plot the point 4 pi over 3, 5, and 10 pi over 3, 1. We know that the upper point will always open upwards. The lower point will always open downwards. And just a reminder that it will never be the opposite way. It will never be that the upper point opens downward and the lower point opens upward so that they overlap. There will always be that space between the two sections of the graph. Now we're ready to check all of our attributes of the graph that we had figured out earlier and make sure everything is okay there. Looking at the graph, we can find the period by subtracting 13 pi over 3 minus pi over 3, which would be 12 pi over 3, which equals 4 pi. So that checks out. The vertical stretch or compression should be a factor of 2. So here's how you can find that on this graph. We know that the vertical center of the graph is going to be halfway between 1 and 5, which would be 3. Then from 3 up to 5 is a distance of 2. From 3 down to 1 is a distance of 2. That's how you can verify your vertical stretch. For the phase shift, we know that unaltered cosecant at the y-axis should be that first vertical asymptote, and instead that asymptote has shifted to the right by pi over 3, and that's exactly what we said we thought it would be. The vertical shift, remember, you can use that vertical center we see is here at 3, halfway between 1 and 5. When we look at the x-axis of the unaltered cosecant, that's where the vertical center is, and instead that vertical center has shifted up by 3 to be here. So that agrees. Our domain is that the x values can't be pi plus 6n pi over 3, which works out to be these values here where the vertical asymptotes are. So that checks out. We expected that the range would be negative infinity to 1, and we can see that piece is here. And then 5 to plus infinity, and that piece is here, so that checks out as well. So we have successfully created our graph for y equals 2 times the cosecant of the quantity 1/2 x minus pi over 6 plus 3.